Hello, everyone. I am delighted to welcome you to this talk about creating end-to-end feature animation pipeline using Unreal Engine in the cloud. I am Rajesh Sharma from Spire Animation Studios, and joining me today, Jacob Feldman from CoreWeave.
Thank you, Rajesh. I think we have a lot of really interesting stuff to cover. We're going to hear from you about your studio, how it came to be, some of the awesome things you're working on, and we're going to talk about how those workflows are cloud native and run inside of CoreWeave using NVIDIA GPUs, and how those three components come together to make something really awesome.
Thanks, Jacob. I am Rajesh Sharma. I am the VP of Engineering at Spire Studios. And in this talk, I'll describe a little bit about our studio, what kind of films we are making, what kinds of workflows we want to enable, and how my team and I are working with CoreWeave to enable all that infrastructure to make that possible.
And I'm Jacob Feldman. I'm a rendering specialist and software engineer here at CoreWeave. And I've been working with the Spire team to help them develop the solutions for their workflows in the cloud.
The goal of Spire Animation Studios is to make high-quality, feature-length animated films that appeal to a large variety of audiences. It was co-founded in March 2020 by Academy Award-winning producer Brad Lewis and PJ Gunsagar, who was co-founder and co-president of Prana Studios. When we started our studio during the pandemic, everyone was working remotely. And not being burdened by a large studio infrastructure or legacy pipelines, we thought that we can provide a radically different collaborative environment, totally in the cloud. So we turned to CoreWeave to help us provide virtual workstations, networking, storage, and render farm all in the cloud.
Yeah, what was really awesome is when you guys came to us, it was an exciting opportunity for our team to take a step back and think about all of the awesome solutions that we could contribute to a cloud native, VFX studio pipeline. So this opportunity felt very special, getting to sort of work with you guys as you started fresh and got to utilize the latest tools, got to utilize the latest hardware, the latest GPUs from NVIDIA. Let's chat more about what you guys are up to.
Collaborative filmmaking. To understand that, let's take a look at conventional studio film pipelines. As you can see, starting from the story and the concept design all the way to the final pixel, the process is fairly linear. There are a lot of iterations that happen along the way, and the movie goes from department to department as it gets refined, adding look development, modeling, rough layout, animation, lighting effects, and then on to the final pixels. For our process, we wanted to break down a lot of these departmental silos so that the artist would have full context in how they're making those decisions. We decided to use Unreal Engine as the basis where we can bring in all the elements of the environment, assemble those environments, capture the story elements, add lighting, do effects, and render it all interactively within the engine itself.
So, what were some of your goals going into this? I remember in our initial conversations that in the effort to make everything cloud native, you were really excited about some of the advantages you would get, and also some of the things that you would avoid, by moving to the cloud and sort of beginning without an on-premise environment.
When we started in the pandemic, we were just looking for workstations for our artists. And the kinds of workstations that we needed with the high-end NVIDIA graphics cards that are necessary for our workflows with Unreal Engine and the level of complexity that we're looking for, they were so hard to come by during the pandemic. So going cloud native for virtual workstations, that made total sense at that point. But then as we are looking to grow and not having any legacy infrastructure to be able to scale that up in the cloud, we're also not only using workstations, but storage and networking and for our render farm needs as well. We want to go all in the cloud primarily because of the scalability and the ease of startup and shutdown and on-demand provisioning of those machines. That makes total sense.
Yeah, I think one of the big advantages that a lot of folks see on CoreWeave is access to scale, and I think going forward, both the flexibility and the access to scale, I think is going to make a huge difference for your team with these collaborative workflows, and also, like you mentioned, access to the wide variety of NVIDIA SKUs that we offer, with things like ray tracing. So one of the really amazing parts of Spire is your commitment to some of these new technologies that you guys will be leveraging. So I'd love to hear more about how this all started. And I know that a piece of that is Unreal Engine and Epic Games.
Last summer, we received an Epic Mega Grant. So this initial grant allowed our artists to get trained and experienced with the power of the Unreal Engine and prototype some of these collaborative workflows that I'm talking about. So we made a small sequence that had complex environments and expressive characters. It also let us push the boundaries of the Unreal Engine in terms of what it can do for rendering, for adding effects, for lighting.
Yeah, I think that's amazing to hear how you guys got started with Unreal. It's certainly Unreal Engine is certainly something that we're very excited about here at CoreWeave, and what that enables folks like you to achieve in the cloud. Let's just chat about it. What do you love about real time? What is it that drew you to it, and what are some of the key advantages that you believe make it a better solution for your studio and the sorts of films you want to make?
At the heart of our process is collaborative filmmaking, and that is enabled by the interactive nature of the Unreal Engine. So, by having full context of the entire environment and the characters within a whole set available to the artist, it makes the iterations faster. So, by having faster iterations, we can get more of them, and the refinement process of whether we want to do reviews or change lighting or move characters, that all can be done interactively rather than waiting for 2 hours or 3 hours for a render to come back in a traditional setting. We can make those decisions pretty quickly because everything is interactive, everything is at full resolution.
Yeah, and it's pretty incredible nowadays, just the amount of quality you can get out of a game engine like Unreal. Were you surprised at all when you started to see the results that you were getting from it?
I think I was a little bit surprised by how much complexity the Unreal Engine can handle. So we threw a lot of complexity at it in terms of our set designs and environments, and the kind of interactive rates we can get while processing all those elements in the environment. And it's been pretty eye-opening. We're also seeing a lot of advances in the rendering engine itself. So not just the interactive rendering engine, but the path tracer that Unreal has that has gotten better over time as well.
Right. It sounds like you guys will be leveraging a pretty good array of the technologies built into these engines. I think from our point of view, real-time workflows are really going to be a major shift in how folks interact with a cloud, given, like you said, things like iteration time. The fact that it's not going to take 45 minutes for a frame sometimes, and when it does take that long, it's already been proven, right? What the look and feel of the scene is. And so, just the time to that final shot, even if you use a path tracer inside of Unreal, it's just dramatically better, right? And I think that's really exciting from our point of view, because it also gives us an opportunity to go out and think about, what real-time workflows mean, for, the rest of the pipeline. In rendering, usually we think of just the render, right, which is most of the time at the end of the process. Whereas, using the cloud for real-time workflows means that you have acceleration throughout that process, right? And with NVIDIA GPUs and what we can accomplish with those, I think it's really exciting for us and our customers to, to think about some of these awesome new tools that will enable future films or future content.
Yeah, I think beyond the faster iterations that an individual artist can get out of Unreal, there are capabilities in Unreal for multi-user editing and even more collaborative workflows. So we're looking forward to kind of enabling those, having multiple artists work on the same set on different parts of it, and even get direct reviews remotely by taking part in the Unreal session directly rather than doing reviews later on. So I think this will open up a whole new set of collaborative tool set that we haven't used before. Pixel streaming is another technology that we are looking at. I think we have this vision of providing full access to the state of the film, whatever state it is in currently, and not just be able to kind of scroll through the entire film, but also look at it historically in terms of versions of a particular sequence or a shot, all the way back into the story stage, and then progressing it as it's iterated upon to make it into the final pixels. So I think having that particular view, either by shot or by sequence or for the entire film in a single interface, that could be one great use of the pixel streaming technologies.
On CoreWeave, we have the ability to scale up workloads, significantly faster because we are a Kubernetes native cloud. So that means, when one of your artists goes to view this film, we can spin up a NVIDIA GPU within, 20, 30 seconds or less, and you can have an artist viewing it immediately, right? There's no delay. You don't have to wait for resources to come up. I think it's really cool to think about the accessibility of real-time workflows as compared to, the sort of traditional VFX pipelines with, things like pixel streaming and the ability to share sort of live interactive content where anyone can go in, visualize the scene, and, get a window into that world you're building. I think it's going to make a huge difference in the number of people who get to contribute, right?
You're absolutely right. Pixel streaming could be a great solution to reviews. If we can stream the film, and on the consuming side, if you can open it up on any device, whether it be a phone or an iPad, you don't need a high-end machine to look at the stream. And if you can give reviews and give input into either a shot or a sequence or even the entire film, that could be a great use of pixel streaming. Beyond the Unreal Engine, we also want our artists to be able to use whatever content creation tool is best for their craft. So to enable that, we are creating an asset management pipeline that is based on USD that allows interchange of data from other DCCs to bring them into Unreal. Again, to make that round trip possible, we need an interchange format that is industry standard, and USD seems like the best bet for it.
Yeah, I think USD is one of those really awesome technologies that, given your circumstances and the fact that you're coming into this with a clean slate, this is, an amazing opportunity to jump on a standard like USD and, take advantage of all those benefits. We're really excited about what, for example, Omniverse is bringing to the table with USD and its ability to, store version USD files and then provide bridges to renderers and, between all your different applications. And we hope that, that's something that we see people continue to leverage at CoreWeave as people become more adapted to the USD workflow. Having a format like USD and, having an efficient way of, sharing those files, collaborating on them also opens up new opportunities for visualization pipelines. One of the things that we had a conversation about was how we could potentially, leverage USD and then NVIDIA GPUs using, pixel streaming to potentially allow you guys to have previews of any asset at any time.
We have automated a lot of this process, and when an artist starts, as part of the onboarding process, we automatically provision a machine for them with the right base image and with the right kind of software that they would need for their work. And the day they start, the machine is ready, and they can just press a button to begin working.
Right. On CoreWeave, you can, change the specification of that VM. It's all managed through our Kubernetes interface. And immediately you're going to get a new VM for that artist that has, potentially a much different GPU. You might be able to attach an A40 and then switch them back down to, an A4000 when they no longer need that hardware. And that on your end, it's going to save you cost and also, give you the flexibility to sort of right size your workflow. What I want to do now is really sort of dig in on this infrastructure piece and start to describe, in detail the sorts of, workflows and solutions that you guys are deploying for your studio. We hear all the time from studios that, are operating on, what's been common in the VFX world for a long time. They'll have a group of on-premise workstations, and they'll swap artists between them, or maybe they'll change the use of some to serve other functions, or render, or this or that, and the flexibility is just not there, right? And it also makes the management of those assets much more difficult, right? We hear all the time about people saying, we have lots of freelancers coming on, especially with COVID. And to suit those people's needs, we either need to go out and buy physical workstations, or we need to look into a more cloud native way of doing things. So this starts by just discussing the overarching infrastructure that we've built here at CoreWeave. So our entire cloud is Kubernetes based, which means all our resources are containerized or otherwise managed by Kubernetes. And that enables us to do a lot of really cool things, like I mentioned, improve scale up times significantly, allows us to create more stable environments with better resistance against failure, and also allow us to flexibly provision resources for customers that give you the flexibility to scale your operation on demand, right? So our VFX solution is sort of broken down into a couple key components, and then above that is what you guys have layered on, right? So this is definitely not the full picture, but it is a picture of how VFX solutions typically look here at CoreWeave, right? So it breaks down into rendering, virtual workstations, and storage being sort of those main components that are generally leveraged here at CoreWeave, right? So virtual workstations is definitely one of the most important ones. It's how your artists get access to the work they need to do. And our virtual workstation solution is extremely flexible. Like all our other resources, you can schedule in any of our regions and move workflows and move artists between regions very easily. And also, like you mentioned, our virtual workstations allow you to quickly change the specifications, so you can have an artist working on like I mentioned in the video, like A40, a top of the line GPU with the best ray tracing and everything, right? And then as soon as that artist is doing a more basic task, they can go ahead and move that down to something like an A4000 or lower, right? And I think that's a really powerful solution, both from a cost saving perspective, but also just being able to quickly scale up means the world sometimes too. We have lots of customers who come in, they're rendering a file and they find out they don't have enough resources, and it's as simple as just restarting their VM, getting an extra GPU, or getting more memory. It's just a way simpler process than having to have someone go to their workstation and alter it, or go to an on-premise data center and switch out the components manually. So our virtual workstation solution is based off an open source project called Kuber. And like I mentioned, it's entirely managed within the Kubernetes interface, which gives you the ability to manage your virtual workstations alongside the rest of your workflows. And that just makes everything a little bit simpler. You guys have gotten a chance to work with our virtual workstations now. What's your impression?
Yeah, CoreWeave provides us with virtual workstations with high-end NVIDIA GPUs, not just for the individual artists, but for rendering on the queue as well. So if we need to provision hundreds of GPUs for a long sequence, we are able to do that, and that's been awesome. Not only that, but sometimes an artist is working on a shot or a sequence that is too heavy, and we can immediately provision a different kind of machine for them with a higher spec, with a higher end GPU and a lot more memory. And they can just jump off onto that machine and then finish their work. Yeah, the logs that come out of the CoreWeave machine usage, they are invaluable to us in optimally allocating resources to the artist throughout the studio. So if we see that someone is not using their allocated machine to the full capacity, then we can downgrade their machine. On the other hand, if we see somebody continuously bumping up against the limits of the hardware, we can allocate additional storage or up their spec to a higher end machine. That flexibility is great to have to be able to start or stop your machine on demand. um, is amazing for an artist. I think if you get an idea in the middle of the night or on a weekend, you can start your machine. It takes less than 2 minutes for an artist to press that start button and be productive. Not only that, but in a pinch, you could take your laptop to a Starbucks. Even with that limited bandwidth, you can still access your machines. And while you're at an office or connected to a high bandwidth area with low latency, it almost feels like the machines are on your desktop. The basic hardware spec is just the beginning. On top of that, we need to layer in all the other applications that the artist will use. So if you look at this diagram, at the basic level, we specify what kind of GPU to use, what kind of CPU to use, how many cores, etc., how much memory to have, what kind of storage, and how much storage to use. And then on top of that, we add in all the DCCs that an artist might use, some of the core libraries like Python and USD. And then we add in the Spire specific tools that are custom made. And along with that, we provide an asset management software that keeps track of all the shots, all the assets in a versioned way so that we can keep track of all of those throughout the production. So all this enables the workflows that our artists would use. And this machine is then provisioned per artist on demand. And of course, we use the CoreWeave machines not just for artist workstations, but we also use it for rendering. Can you describe a bit about how rendering is set up at CoreWeave?
Yeah, absolutely. So our rendering solution is a managed deadline solution, which is what you guys are leveraging. And our managed deadline solution utilizes a project called Kita to auto scale deadline workers for all of the rendering tasks. So inside of Kubernetes, we provision, containerized rendering workers on demand. So you submit a job to deadline. We use our Prometheus metrics to pull information about those jobs and then automatically scale our deadline workers to meet those needs. And that means, you can go from 0 to 1,000 deadline workers, within a minute, right? Which is just something that you can't accomplish, on other clouds. And certainly it's something that would be very difficult to manage manually, right? Every time you submit a job, having to manually spin up and down resources in order to, save money on, idle compute is a huge pain, and it's just greatly simplified with what we've designed here. Now, you guys are also leveraging Movie Render Queue, which is something we're really excited to bring to these solutions. And Movie Render Queue, it is going to be an amazing way for you guys to accelerate this vision of, utilizing Unreal Engine for everything within your workflow. And one of the things people don't realize about cloud native workflows is that with access to scale, it costs the same to render every one of your frames in parallel as it does to render them in sequence, right? So there's no downside to getting your jobs done quicker, right? We can just simply provision more hardware and have it spin up automatically, and you get your jobs done quicker. It costs exactly the same as slower, and in pretty much every case, VFX studios prefer quicker. So the last piece I want to chat here about is storage at CoreWeave. So at CoreWeave, we have both NVMe and HDD storage tiers. Our NVMe is extremely high IOPS that we utilize for things like virtual workstations or for applications that are directly mounted into our containerized solutions. And then we have our hard drive storage tier that is for large volume storage, and for folks like you at VFX Studios, this is critical because you guys have lots of files. And all our data is triple replicated. which means you're protected and your files are safe. Our storage enables you to, like we said previously, scale up and down dynamically as well, right? You can provision storage, and then as your shots grow, as your outputs grow, that storage can very flexibly scale to meet those needs, without having to pay for a storage server, right? You guys don't need to go out there and buy a bunch of hard drives just because you wanted to, start a new show and you didn't want to have to archive the old one, right?
Storage is a critical piece for us, and we know it will grow as we build a movie. The storage for an entire animated film can be in the hundreds of terabytes. Not only that, but it's not just one kind of storage. There are images that are generated, obviously, and then there is data that goes into making those images. There's a lot of simulation data. Different kinds of data would need different kinds of memory. Textures that are accessed very frequently will need to be on a high-speed storage that needs to be accessed pretty quickly.
Right, and it's controlled exactly the same. I think some people don't realize, how important storage is to, VFX workflows. But particularly when we're talking about cloud native, how you handle your storage is essential to, the efficiency of your pipeline. The thought of having to work locally and then anytime you wanted to scale to the cloud, having to transfer those files is a major blocker for a lot of people, right? It's just not practical sometimes to transfer hundreds of terabytes of data, for a render, right? With the cloud native workflow that you guys have designed and we've enabled, your storage is living in the same place as all your other resources, and all your other resources have access to that instantly, with extremely high performance, right? And that means there's no delay between when you need to render a job and when it's actually rendered. Thank you guys so much for coming to our talk. It was really exciting to speak with you, Rajesh, about the things you guys are working on. We're really excited to be your partner through this process, and we're really excited to see what you guys do. So with that, we'll be answering questions throughout this talk through the chat, but we'll also have a follow-up after party for those of you who want to chat with us directly and have additional questions you want to ask. And with that, thank you guys.
Thank you, everyone.